Okay, so sometimes when we do elimination, we have to scale up or scale down the equations by multiplying. So there's an extra component to this. The coefficients won't look exactly the same. One might be twice as big as the other, so we're going to have to do something to change it. So same idea, though. We're going to start by putting the equations in standard form. Okay. Still determining which variable to eliminate, but now we may have to multiply one or both equations just to get the variables to make sense. In order to do that, we're going to multiply one or both equations by some constant. So we might multiply the whole equation by 2, 3, something like that. We're going to solve for the variable, and everything else is the same after this. Once you solve for the variable, you still plug back in to find the other, substitute it in, and then, as always, check your solution with both equations. Okay. So I'm going to look at this first example here using the 5-step process as a guideline. All right, so we have 2x plus 2y equals 6 and 3x minus y equals 5. Well, it's not quite ready to be added together to be solved. However, I see that 2y and negative y are pretty close. They differ by a factor of 2. So if I were to multiply the negative y by a 2, I could actually cancel out the y's. So whatever you do in an equation, you guys should know you have to do to both sides. So the way it's going to look is like this. I'm going to multiply the whole thing, the whole bottom equation, by 2, which is essentially like distributing. Every term gets multiplied by 2. So I like to rewrite everything. So it's 2x plus 2y equals 6 again. The bottom's going to look like this. 6x minus 2y equals 10. Notice I've scaled it up. Now, identifying that they're opposite variables or opposite coefficients, I can just add them together. So I get 8x, cancel the y's, equals 16. Well, that gives me an easy answer of x equals 2. Now, what's nice about this process is I can plug the 2 back into any of the equations I have here. So I'm just going to go with the top one again. So plugging 2 in for the 2x plus 2y equals 6, I get 2 times 2 plus 2y equals 6. All right, so that's 4. I'll subtract the 4 over. 2y equals 2, divide by 2, y equals 1. So it looks like my answer is going to be 2, 1, but let's make sure. We'll verify. I'm going to use the top and bottom equations to make sure they work. 2 times 2 plus 2 times 1 equals 6. That works. 3 times 2 minus 1 equals 5. That also works. So there's my solution. Okay, so I'm going to do a couple more and then see if you guys can try some. Okay, so the big question is, what do we multiply by? All right, I'm looking at the first one here. I'm going to multiply the top function, or the top equation, by negative 2. I'll show you why. If I do that, negative 2, I'm going to get negative 4x plus 6y equals negative 12. The bottom's going to stay the same. Okay, and essentially this would allow me to get rid of my y's. Okay, and then you would just continue with the process. If I wanted to eliminate the y, actually I did this backwards, so sorry about that. All right. This is for the y, this is for the x. So let's just flip-flop that in our notes if we can. Okay, so then this one, we want to get rid of the x. Okay, this one's going to be a little harder. I would have to multiply this one by 3 and this one by 2, because what I want to do, or negative 2, because what I want to do is make both of those 6's. So that would give me 6x minus 9y equals 18, and a negative 6x plus 12y equals negative 16. And as you can see, the x's would cancel here. Doing this the same way, I'm going to just do y then x like I did because I messed up initially. All right, so to eliminate y, I would just multiply this by 3. So that's going to be 5x minus 3y equals 7. 6x plus 3y equals 15. Notice I'm good to go when I add the y's together. They disappear. All right, similarly now, I'm going to try to find the x's. All right, so I'd have to multiply this whole top thing by 2 and this whole bottom thing by -5. You're basically trying to make two numbers that are the same but opposites. So this is going to be 10x minus 6y equals 14, and negative 10x minus 5y equals negative 25. Just make sure you multiply everything by that constant. Those go away, and now I'm good. There's some u-tries at the bottom I'd like you guys to try. It's just the same process, but you can do it in the order that's written. Try to eliminate the x's first, then the y's. Okay. We have some more examples, so I'm going to just do those out with you guys in real time here, and then there's some u-tries to finish this off. All right, so I'm going to solve for y first by multiplying this by -2. Remembering I multiply the -2 by everything. Okay, I'm going to add together and cancel. X minus 8x is -7x. 3 plus -10 is -7. Oh, that just gives me +1. Plugging back in to the top, 1 plus 10y equals 3. Okay, so subtract 1 on both sides. 10y equals 2. I'm going to get an interesting answer here. Y is going to be equal to 2 over 10, or 1 over 5. Okay, so it looks like my answer is actually going to be 1, 1/5. All right, looking at the next one over here. This one's a little harder. I think I want to make the x's the same, but in this case I have to multiply both of them. So I'm going to multiply this one by 3. Multiply this one by -2. And you'll see why. So I get 12x plus 15y equals 18. And negative 12x, there we go, plus 14y equals +40. Adding them together, x's are gone. 29y equals 58. Oh, that actually works nicely because that makes y 2. All right, plugging y into the top equation to get x. Oops, that's supposed to be a 5 right here. 4x plus 5 times 2. So that's 4x plus 10 equals 6. Subtract 10. 4x equals -4. Therefore, x equals -1. So it looks like my final solution is -1, 2. All right, why don't you guys try the u-try on the next slide and see if you can figure this out.